Hello everyone, welcome to this webinar. My name is Amit Joshi. I'm a professor of digital marketing and strategy here at IMD.
Hi, I'm Gautam Chalagala. I'm a professor of strategy and marketing at IMD. Welcome to this webinar.
So we're going to kick it off just to let you folks know, if you have questions, feel free to put them in the question box, typing it in. We'll be able to see it on this device that we have over here. We'll take all questions at the end of our webinar, but feel free to type them as we go along, as you have questions on the things that we are raising. Right?
Excellent.
So with that said, let us get started with this webinar. Once again, thank you very much for taking your valuable time to join us here, and we'd like to kick it off. So we're just going to kick it off with some really basic questions, right? We want to talk about, first of all, what is AI? What is artificial intelligence? You know, what comes to your mind when you think about the word artificial intelligence? I mean, don't think of a textbook definition, because I don't think there is one, but what really comes to your mind? And, you know, Gautam and I, we talk about these things quite often. And what we realize is, talking to executives, is that if you talk to 10 executives about what AI is, you'll end up getting probably a dozen answers on what they think artificial intelligence really is. There really is very little consensus on what AI is. More importantly, there is a lot of misinformation and hype around the term artificial intelligence, in terms of what it can do, in terms of what its capabilities are, in terms of what its applications are. And which is the reason why both Gautam and I, we really got involved in this area, because we realized that this is an area that's obviously the future. Both of us truly believe that. But more importantly, there's a lot of misinformation and hype which we would like to clear up. So I just want to start off by telling you our visualization of artificial intelligence, or our interpretation of artificial intelligence. And what we think is that AI is nothing but a superhuman pattern recognition machine. So let's break that down a little bit. So let's start with the pattern recognition form. So literally, the artificial intelligence, which more appropriately should be called machine learning, honestly, the machine learning techniques that we have today can really do one thing very well. And that one thing happens to be pattern recognition. At pattern recognition, however, the systems that we have built today, the machine learning algorithms that we have today, are absolutely superhuman. They're beyond anything of what our brains can do. They're beyond anything any other machines that we have built can do. So in that one thing, these devices really are superhuman. Now what you're seeing on the screen in front of you is a AI. It's a machine learning algorithm that's been built to recognize handwriting. Okay? Pretty simple machine learning technique. If you have some basic programming skills, today you can actually download some free software from the web. You can train your own system to recognize handwriting. So that's where we've gotten. We'll talk about that in just a bit. But look at this. I mean, these are various different handwritings. Some people are blessed to have good handwriting. If you're like me, I have really horrible handwriting. My handwriting is really terrible. And my T might sometimes look like image number 2 or image number 3 in the upper part of the visuals that you see. And you know, sometimes even I have trouble deciphering my own handwriting if I look at it later on. However, this is what I mean by a superhuman pattern recognition engine. At the end of the day, if you agree that writing is nothing but a pattern, we have created a device that can recognize even the worst handwriting, even a squiggle that perhaps only few people can understand as a T. But if you notice below, and below is the interpretation of what the machine thinks the thing above is, it has absolutely no concern in understanding that what is written is actually a T. It's pretty cool. And if you're thinking, okay, this is cool, but so what? Well, think about it. Every time you pick up your cell phone and talk to someone at the other end, a system very similar to this system is basically running in the background. It's pattern recognition, because a voice is a pattern. It's needed because in even the most high quality transmission, perfect information is not transferred. Whatever you speak is obviously converted to zeros and ones. You know this. It's transmitted over the cell phone network or the phone networks, and a good amount of it is lost on the way. So at the receiving end, we need some sort of a pattern recognition to decipher exactly what the original zeros and ones were and then convert them to voice, which is why, the applications of these systems are really amazing. So once again, the way we envision artificial intelligence, the way we like to think of artificial intelligence is nothing but a superhuman pattern recognition engine. So let's understand this. It can only do one thing. However, that one thing it can do at an absolutely superhuman level. It can do it at levels that you and I and basically every human being on the planet would simply not be able to match up, but in that one thing. So in that sense, I often like to say that we tend to overestimate what AI is capable of. So remember, AI, literally, the machine learning algorithms that are existing today, no matter how complicated, really are just pattern recognition. They can do one thing, but they can do one thing really, really well. But what I also say is that we really underestimate on how machine learning can be applied. So the moment we say AI just have one capability, you might be thinking, well, then its uses are fairly limited. What we're going to discuss, what we're going to really talk about is the fact that even if the only thing this thing can do is recognize patterns, and recognize patterns at an incredibly powerful level, the applications for a technology like this in today's day and age are absolutely immense. Simple thought experiment. Think of this for yourselves. Think about the tasks that you do on a day-to-day life, and think about how many of them are actually pattern recognition tasks. A large portion of what we do on a day-to-day basis is actually recognizing patterns, right? And if I'm now telling you that we have a machine, we have a system that can do pattern recognition at a superhuman level, you can then start seeing the potential applications for this particular technology. So again, very, very narrow in terms of its capabilities. What we have today is what's known as narrow AI, artificial narrow intelligence, AI that can do a very, very tiny task, a very, very focused tasks, but at an absolute superhuman level. Having said that, I want to reiterate this. The kinds of things we can use this for in day-to-day life, in organizations, in your job, in your work, are absolutely immense. And hopefully we can touch upon a couple of these things over the next few minutes. In terms of, if you think back to what you might think AI is, or what most people might think AI is, what they're usually thinking of is what would be considered artificial general intelligence. Now, this is the concept of machines. This is the concept of artificial intelligence that can do everything as well as a human being. What I'm here to tell you is, we are nowhere close to artificial general intelligence. We are at least a few decades away, depending on which scientists you're speaking with, depending on which experts you're talking to. Maybe we are hundreds of years away, not even a few decades. Bottom line, we are nowhere near AI that can replace human beings in general tasks. So if you think of the hype curve, this is the hype curve that's been proposed by Gartner, and this hype curve basically talks about how technologies evolve in terms of what we expect of them. And the usual pattern is whenever we see a new technology coming up, there's some kind of a trigger. It could be a newspaper article, it could be a scientific publication, it could be a release by a massive company, Google or Facebook start talking about it. And then all of a sudden, everyone starts talking about how this particular technology is going to change everything we do. It's going to change work. It's going to change how we live. It's going to change how we do our jobs. And that would be the peak of inflated expectations. Think back to technologies over the last decade or so. We are coming to the end of yet another decade, the second decade of the 2000s. Think of the past 10 years. We've had a bunch of technologies like that have gone through the peak of inflated expectations. Blockchain is just one example that comes to mind. Perhaps 3D printing is another one. And I'm sure you can come up with more examples on your own. After the peak of inflated expectations, most technologies usually fall to the trough of disillusionment, where we realize that they really cannot live up to the hype that they have been subject to. In some senses, it is our feel that AI will eventually go through this trough of disillusionment when people actually realize that it's kind of just a pattern recognition engine, not really something that can replace us. In most of the things that we do, there will be a trough of disillusionment before we eventually land up at the plateau of productivity on the extreme right-hand side, which is when we actually figure out real practical uses for that particular technology. They're never going to be as hyped up as we thought they were, but nonetheless, they will be extremely practical. They will eventually change our lives, but maybe in really, really small ways. So right now, if I were to guess, I would say that artificial general intelligence, the concept of AI that can replace everything, that can replace human beings, is probably in the peak of inflated expectations. We are nowhere close to this. On the contrary, if you think about artificial narrow intelligence, pattern recognition and pattern recognition alone, I would claim that that is already approaching the plateau of productivity. We are already very, very close to having real commercial applications of artificial narrow intelligence. Gautam and I, we deal with organizations all the time. We are starting to see more and more organizations mature in using artificial intelligence, in using machine learning to help, to aid in do the things that they do on a day-to-day basis. So once again, artificial general intelligence, intelligence that can replace human being, peak of inflated expectations, nowhere close to reality. Artificial narrow intelligence, AI that can help, AI that can do pattern recognition, plateau of productivity. We are very, very close to actually commercializing those things at scale.
So thank you, Amit. Just wanted to say that, we hear a lot of terms when it comes to AI, and actually there are different types of AI. And Amit referred to what we call as machine learning. But actually, if you think about AI, there's really two basic forms of AI. And the first one is what we would call as an expert system. And this is something that has existed for decades. A lot of the stuff we're talking about AI now is not so new. A lot of the expert systems were born in the 1940s and 50s, where they were initially sort of crafted. And so for an example, the way we think about an expert system is what we call as rule-based artificial intelligence. So what does this mean? You might design a rule to say, should I give somebody a loan or no loan? And you might have a formula for doing that. That's an example of an expert system. There is no learning involved in this kind of artificial intelligence. Is it still useful when there is no learning involved? So for example, as new data comes in, it doesn't take into account the new data. It sticks to what the rule is. And if there's very fresh, disparate data that comes in, the algorithm cannot make any adjustments, okay? Or the formula remains the same. That's what we mean. There are still some very, very clever applications, and we still need expert systems. Just to give you an example, when Amit and I, we visited Waymo, which is the Google self-driving car when we were in Silicon Valley. And one of the things they said is, we don't want the car, the self-driving car, to always take the shortest time possible, because that might mean breaking a lot of the traffic rules. So for example, if there's a red light and another car passes by and it's breaking the rule, then if you have a learning mechanism, it says, oh, wait a minute, if I go now fast, then I will reach my destination faster, and that's a good thing. But this is where expert systems kick in, where you have a rule which says, no, if there's a red light, do not start the car till it goes to green. Okay, so expert systems have a wide range of applications even today, and will continue to play a prominent role into the future. Okay, so that's the one type of expert system, one type of AI. The second type of artificial intelligence that we often talk about is neural networks. And this is where what scientists have tried to do is replicate the brain. Because imagine if you had to write a rule in terms of what is a cat. That would be really hard. So we have to think about how does the brain learn what is a cat, right? And so how do we learn what is a cat? Our parents, for example, show us a lot of images of cats. When we are walking somewhere with you holding your parents' hand, they might point and say, that's a cat. Then we get it through books, your ABC. I think it's almost universal that the letter C is for cat, right? And that's how we learn what is a cat. So what they've tried to do is figure out ways to write rules. Ways to emulate how the brain learns, and this is called neural networks. And this is where you hear the words like machine intelligence and deep learning and so on come through, because they're really trying to emulate how a human brain works. And this is where this form of AI is not new, but there have been some breakthroughs in the last 1-2 decades that have made it commercially viable. We're still trying to make more things commercial and economical, but this is where a lot of the breakthrough ideas and thinking has been going on. This is where machine intelligence and deep learning fit. They're nothing but types of neural networks. And the fundamental thing for you to remember when you distinguish between expert systems and neural networks is one is rule-based, and there's a rule, and somebody has to go and modify the rule on their own. There is no learning. With neural networks, you don't need to necessarily write the rules, and it can learn on its own. Okay? Or you might give it an initial rule to get started, but then as new data comes in, it learns just like a human brain learns. So think about neural networks as doing some kind of a diagnosis and then getting better at predictions. Okay. Now, just to show why this has been so prominent, Google, for example, bought this company called DeepMind. And they bought this, I think, about 5 or 6 years ago. And this became what we could say is the moment when the world truly woke up to the power of artificial intelligence. Now, we've had artificial intelligence for decades, off and on. We've had people talk about it quite a bit, but they usually gave up after some time. Not the expert system side, but on the neural network side. But the world truly woke up when Google's DeepMind, a London-based, a UK-based company, beat some of the world champions at the game Go. And that was when, for example, about 280 million Chinese folks watched that game live. And that's when the government of China woke up. That's when, Western business corporations and Western governments woke up saying, my God, AI can be very, very powerful. But again, I want to go back to a point that Amit raised before, which is it is still doing predictions. That's all. That's the only thing that it does, is looking for patterns in data and making predictions. Now, but this is not always easy. Just to give you an example, here, if you look on the top left, here's a generic bottle of oil. Could be some kind of a vegetable oil, right? So you could say this is from sunflowers and there's oil. So, from sunflowers, we come up with oil, and that's a sunflower oil, and it could go into that bottle. Similarly, you could make oil from olives, right? And so that's how we have olive oil, which goes into a bottle. But now you think about it, there's baby oil. Is baby oil made from babies? Obviously not, right? So So while this is where, there are still lots of things and advancements that are happening, making sure that when artificial intelligence encounters things like this, that it can make the right assessment that baby oil is not made from babies. And that's why, while it may sound simple, even mastering languages, more importantly, mastering the nuances of languages is where a lot of the progress is happening today. And that's why even today natural language processing has made just enormous strides. It's really almost as good as humans, perhaps will exceed humans pretty soon, but there are still some of these nuances. And the real trick and the real question is, when will we overcome that? And when will we find it to be so economical that anybody could use it? Okay? And this is where I want to go back to a point that Amit made repeatedly. There are just an infinite number of applications for AI. For that one simple narrow thing that it can do, the number of applications is enormous. If you reflect upon your own day, or just take the last 1 hour, you probably, as an executive, spent a fair amount of time making predictions on, or should I enter this market? How are you deciding? You're making predictions based on data, patterns that you've seen before. You may say, well, we've been successful in South Africa. Maybe this market has many characteristics that are quite similar to South Africa. So I think our chances, based on some objective data and our previous experience, which is what? Pattern recognition, you are making those assessments. You are making predictions when it comes to hiring, right? When you hire a person, you are really predicting whether this person will be a good fit for your organization. You're really predicting whether this person will be a good fit in your team. You're predicting whether this person will be a hard worker. You're predicting whether this person will come up with, breakthrough ideas. So most of what we do is around predictions. So as long as there is the right type of data, AI could be enormous. Just the number of applications is staggering from that standpoint. But, one of the things about this topic is we gave it, we called it AI, the good, the bad, and the ugly. And just like recognizing patterns in numbers, recognizing patterns in words, which was a previous example, it's also about images, right? So if you look at in 2014, the kind of images that AI created were, not very good. It's very grainy, and any one of us would look at it, would say, that's pretty awful. A decent artist, a decent street artist can do a better job. And these are people who are just sitting on the streets, right? They're not that great themselves, but a decent street artist can do a better job. But now, if you look at 2018 and you look at that and say, wow, this was created by AI, can our human eye really recognize whether this is a real image or a fake image? And so this is where some of the bad and ugly start coming into place with AI, because there are many, many good, powerful applications, but there's also some of these things about, how, we might fall victim to deep fakes and so on. I recently had an executive tell me that the CFO or maybe the accounting controller of a company transferred money believing that he was listening to the voice of the CEO, and that was actually an AI replicated voice of the CEO. That was nothing but a deep fake. So there is the bad and the ugly side of it, and I just happen to know one company that fell victim to this. Okay, so let me turn it back to Amit.
So thanks, Gautam. This is absolutely fascinating. So just to kind of tie this discussion together, I think our big picture message is that applicable narrow AI is here and it's here to stay. Again, I'm saying this, and Gautam and I, we keep repeating this, but it bears repeating. This is just a system that can do one thing, pattern recognition, but it has tremendous amounts of applications. It's not going anywhere. And implemented properly, it promises to make all our lives better. Right? I mean, the example that Gautam gave, I mean, of course, we're going to have unfortunate individuals who are going to try to use it for negative things, who are going to try to misuse this particular technology. Happens with each and every of the technology that we have ever invented as human beings. Nonetheless, we strongly believe that over time, as we figure out positive implementations and positive applications for this technology, it does truly have the potential to make all our lives better. Andrew Ng has called AI the new electricity. Now think about it. Does electricity have the potential to electrocute you and hurt you? Of course it does. But think about how our lives have entirely changed, without a doubt, across the world for the better since the arrival of electricity. Okay? Without doubt, everywhere in the world, all 7.5 billion of us today lead a much better life in multiple objective ways than we did before we had electricity. AI promises to be a similar kind of technology. Now, as an executive, there are several aspects about this whole change, about this whole transformation that you really need to understand. The most important thing that Gautam and I think is necessary for you is understanding the intuition behind this technology rather than the programming or the technical details or exactly how a deep learning neural network works. You probably will not do this yourself. As a matter of fact, we would go so far as to say, if you are already running deep neural networks yourself, if you are programming them yourselves, then perhaps what we have to say may only add marginal value to you. However, if you want to think strategically about the strategic impact of these technologies on you, on your organization, on the future of work in general, then I think we do have something really, really interesting that we want to talk about. This is a technology that has massive tactical as well as strategic impact on you, as well as the kind of work you do. Think about it, like we discussed, how much of what you do is really just prediction and pattern recognition. It's a massive portion of what all of us do, either in our personal or our professional lives on a day-to-day basis. At the same time, we should not turn a blind eye to the potential pitfalls. Of course, AI can exacerbate the bias that already exists. Think about it. Gautam mentioned two specific types of AI, expert systems and deep neural networks. In both cases, it's humans who train the expert systems. It's humans who provide the examples to train deep neural networks. What if our examples themselves are biased? What do you think is going to happen to AI? AI or machine learning itself is not biased. It's a system. But if we teach it to be biased, of course it's going to be biased. If we teach it to be unethical, of course it's going to be unethical. If we teach it to imitate somebody's voice when we should not do that, of course it's going to go and imitate it. It does not have its own brains in the same sense that you and I do. So of course there's potential pitfalls which need to be discussed, which need to be understood before you go to scaling up the implementation of this kind of a technology. And finally, there's a need to kind of put this together around a framework in a really systematic manner. So this is where the field of machine learning, artificial intelligence stands today. We've made a lot of technical progress. Having said that, we are still in a situation where this system can do one thing, but with tremendous potential impact on a lot of the things that we do. With this in mind, we would just like to spend a little bit of time talking about the AI course that we are now going to be starting at IMD beginning the 5th of Feb in 2020. And the structure of the course, which Gautam and I will be co-directing, the structure of the course is going to be quite similar to the kinds of discussions that we had in this particular webinar. So we're going to start off by talking about exactly what is AI, the history of AI, how AI has evolved over the years, And then we're going to be talking about the business impact of AI. Gautam?
Yeah, thank you, Amit. For sure, this is not a course that is for those who are coming in with how do I design a better algorithm, or what are some of the technical things. Should I use this type of an algorithm or that type? Perhaps you can come and teach me then, because that's definitely not my expertise.
Clearly, yes.
Okay. So this is a course that is really pitched at, I would say, mid-management to higher level executives who are really thinking about, I hear all these confusing terms. First, I want to get a good grasp at it.
Absolutely.
Second, many consulting companies are coming and pitching AI and actually charging astronomical rates for what was previously done with very simple statistics. In fact, many of them, I would argue, even today, are running very simple statistical analyses and calling it AI and charging astronomical rates for it. So part of what we want you to walk away with in this course is to be knowledgeable enough to ask the difficult questions so they cannot fool you. Nobody can fool you. You can walk into a conversation, not get sort of mesmerized or feel diffident because of all these confusing words and terms, but you can say, I got the basics, I know the fundamentals, everything else is jargon, I can ask the right questions. I would say that's a very big purpose of this course, which means everything that we approach will have what is the business impact. Where can it have incremental effects? AI, where it can improve your forecasting models, for example, your prediction models on which customers will churn or which customers will stay with you. To actually recreating business models using AI. And what we mean by that is those models or those ways of doing business would not have existed but for AI. So these are new applications that we could not have done. And we could not have created these business models if AI did not exist. So we're going to really take that strategic perspective, to simplify things, enable you to ask the right questions, and truly understand its business impact, everything from incremental to actually quite disruptive. Okay, I'll turn it to you now.
Absolutely. Just to add a couple of things to what Gautam said, I completely agree with Gautam. The purpose of this course is not to be a technical course. None of you is going to come here and do dynamic optimization or run a neural network, because probably none of you will do that when you go back on Monday morning and do that in your organizations. On the contrary, if you are in a position to decide a budget, if you're going to decide on whether to invest in artificial intelligence, machine learning, expert systems or not, if you are in a position where you have a team below you that's actually implementing some of these things, or you're part of a team that's actually implementing this in your organization, absolutely we feel that we can tell you something that'll add value to you.
Exactly.
And the one more thing I'd like to add is that we're going to keep this course extremely applied. We are setting aside time in the course for you to reflect and for you to apply this, not in the context of the examples that Gautam and I will share with you, but in the context of your specific organization. Our goal is to give you a framework. Our goal is to give you the tools which will help you apply these fundamentals to your specific situation, to your problem, the kinds of problems that your organization, your department, your division is facing, and hopefully leave the course with at least the beginnings of a roadmap on how to crack this. Now, we are not going to promise that in 2.5 days you're going to solve all your problems related to machine learning. That's not going to happen, right? So we're not going to make that promise, obviously. But what we can do is we can give you the tools and we can give you the time to think about how those can be applied in the context of your organization so that you do leave here in a much better frame of mind, with a much deeper understanding that strips away the hype, that strips away the jargon around all of these technologies and leaves you with a much more practical, applied kind of knowledge base that then you can go and apply.
And just to sort of build on that, and then, we want to leave enough time for questions here, is, thinking about the broad-based applications. And I think that's very important to understand, whether it is innovation. I think innovation is broad-based because you can have innovation in every single function. So everything from HR, for how you can use it for hiring, for example, all the way to new product development, to creating new business models, right? What are some of the challenges companies have faced in scaling up AI in their organizations? And so what are some of the pitfalls that you need to be looking out for? And of course, super important, as Amit said, a machine is only as good as the input, right? So what are some of the biases and ethical issues that you're going to be confronting if you're not careful? And how you might have regulators or social media on your back if you're not super careful, right? So it's really to make a manager, an executive understand when and where to deploy AI, when it will work best, what it will give you in a realistic way, and so that you can be a much more knowledgeable sort of decision maker around AI. Of course, we took about 10-15 minutes here to give like our pitch for the course. But part of this webinar is not just to pitch our course, but to give you an opportunity to ask us questions. That way, we address things that are important to you as well. And we've deliberately left about 20 minutes or so for that. So we welcome questions. What we're going to do, Amit and I, is actually scan the questions. I think there's one by Yannick here, Amit, on
NLP and speech processing.
Yeah, on NLP and speech processing. I'll address this very quickly, Amit. Feel free to jump in. Think about AI is going to be very good whenever there's a pattern, right? By now you're tired of us saying those words. But language is nothing but rule-based systems created by human beings. Why did we create those rules? So that you and I can recognize patterns. That's it. It's as simple as that. When there is rule-based systems, or there's a pattern here in language, just like accounting is a profession full of patterns. If you think about law is a profession full of patterns. They're all man-made rule-based systems or human-made rule-based systems. AI will be fantastic with that, within certain boundaries, because there are gray areas. In language, we have a lot of idiomatic usage, as we say, right? Hit the ball out of the park. If you've lived in the US and you're 4 years old, you know exactly what that means. But if you've lived outside the US, you might scratch your head. What the hell does hit the ball out of a park mean?
Exactly.
Right? Similarly, the machine is only as good as whether it has encountered these and it has contextualized them within a particular framework. And so, NLP and speech recognition will be the areas that will naturally develop the fastest, because there's most amenable for these kinds of decisions.
I just to add one more thing to what Gautam said, I absolutely completely agree with what he said, of course, but this is one area of application which was very hard for us to crack before. I mean, like Gautam said, there's too many combinations in languages, right? I mean, and what's more, we keep inventing new stuff. There's always new cool terms that come up. There's always new idioms that come up. There's new applications. Rule-based systems are going to have a hard time catching up. However, machine learning, deep neural networks can actually do this, which is why this is going to be one of the, one of the breakthrough areas of application of machine learning that we are actually seeing in organizations as we go ahead. So absolutely, NLP, natural language processing, and speech processing is absolutely a core area of machine learning applications, primarily because, like Gautam said, it is nothing but patterns. That's it. So again, please feel free to jump in with your questions, and we are happy to address them over the next 20 minutes or so that are left.
So it seems like there's a lag.
I think there's a lag, yeah.
So we have to give them a little bit of time. So, you know, we really look forward to your questions. Make sure that you do that. Yeah, I think the AI course is distinct enough that you could start your diploma with the AI course, and it will not take away anything from any of the other courses. I think one thing that we're going to be quite careful, Amit leads a course on digital analytics, right? There, you get into the technical stuff a little bit, right?
A little bit, yeah.
I lead a course on digital marketing strategy. So both of us participate in leading digital business transformation. So we are very cognizant of the things you've heard of already. And we're going to keep this distinct and a deep dive into just one topic. But no problem in terms of sequence.
So we have a question here. It says that is the power in the data? Is AI without data useless? Are you touching on the ethics of collecting data in the course? So let me answer the last part first. We definitely will be talking about the ethics of AI. This involves both the ethics of getting the data, setting up the AI, as well as the ethics of how to actually implement AI. How to ensure that the AI itself is ethical, but then implement AI in a way that itself is ethical, which is not, for example, taking away millions of jobs. Not that we predict this is going to happen tomorrow, but nonetheless, this is something that we need to keep an eye open for. The first part of your question is the power in the data? And the simple answer to that question is, depending on the type of AI that you're dealing with, the simple answer is yes. Data really are what is driving a lot of the amazing developments that we are seeing with this. So yes, without a question, the power is in data for a lot of this.
So there's a question by Vladimir and David. So let's start with Vladimir.
Mm-hmm.
You want to read it out?
So the question is, do you think NPV, PI, and other similar economic indicators are applicable preparing business cases for development for machine learning-based solution for a particular problem? So I guess the question is things like net promoter value and other similar indicators applicable for preparing business cases?
Or net present value, perhaps.
Or is it net present value?
You might be thinking of net present value, perhaps, and I wonder if PI is like a production index or a producer index. I think it would be good if you can just clarify your question a little bit more, Vladimir. So we'll come back to you once you clarify exactly what you mean. But I did see David's question, will AI transform real estate? It has big potential, right? Now, one thing we always want to be careful of is, I remember reading so many reports saying real estate is transformed forever once the internet came on board and that real estate agents would disappear, right? That has not happened,
clearly,
right? We've seen that transformation in travel, for example, right? Mm-hmm. But it just did not impact real estate the same way that we thought it would, meaning elimination of the real estate agents. But does it have impact on real estate? The internet did transform how we look for properties. It did transform the job of a real estate agent. Now you add images to it.
Absolutely.
I can now, instead of doing a search around, certain parameters of how many bedroom homes, I wonder if there's a way to say, I want to look at, images of bedrooms that have a certain aesthetic feel, right? And so it can look at the images out there and it can isolate what that aesthetic feel is for you. So anything that has images, when you put 1 million images together, now they can detect patterns. Right?
Just to add to that, I think real estate valuation, because it's a pattern recognition thing.
Pattern recognition.
Insurance in real estate for sure is going to get impacted or is getting impacted at least in a little way. So the answer to the question is yes. Matteo has a question: what are the barriers to adoption across small and medium businesses for technologies like this? I mean, again, the 2 or 3 things that obviously come to mind is the availability of data, the resources to implement some of these things. Some of these models are extremely easy, extremely cheap, simple to implement today. Others are significantly more complex. In my opinion, the barriers to entry need to be matched up against what problem they are solving. Is the value provided by machine learning, artificial intelligence, or these systems sufficient to cover their costs? It's a very, very much a business decision rather than anything else. I'll let you pitch in. Go.
I think that's very well said, Amit, that today it's not cheap to find this talent.
Indeed.
Okay? I'm sure this was the same case when people were building high-rise buildings 100 years ago. It would be super hard to find the talent to, put up a big building. Same thing about making cars, right? That knowledge was very localized. It was there among a few people. But over time, once schools really have taken it seriously and they've seen the potential, now even in high school, they're getting exposed to artificial intelligence, right? So the answer is today there are significant barriers, and the biggest one would be data. Second is the cost of the talent. The cost of the talent problem, I think, will be solved faster than the data problem. Meaning, the data for a small business trying to, when you're trying to keep your head above water and just, manage day to day and survive, and then you start thinking about all of the data and creating these kind of databases is not going to be cheap. But the real trick there will be not whether you need to build all the data on your own, but what external data can you tap into that can give you insights into managing your business. So the data side will, I think, be kind of still hard, but will become a manageable problem also in the future.
So he just has a follow-up question which says, do you think this technology will therefore increase the gap between large corporations and small and medium businesses?
So I did see a study on this before, and what is clear is this study, and I can't remember the source, so forgive me for that. What this study showed is something quite interesting, which I did not expect. And it showed that companies making proprietary investments in technology, meaning certain infrastructure things they outsource, right? Maybe you go to Microsoft Azure or an AWS. So I'm not talking about the storage of data and things like that, but really about the insight part of it, analyzing the data, dealing with problems that others may not be looking into in your industry. So investments in, that's what I mean by proprietary IT. That is leading to remarkable differentiation among customers. Now, who is able to make those investments? It is the big firms. So yes, the gap from that standpoint, they do have an advantage. But remember one thing, big firms are big firms. They have massive advantages like the ones I described, but they also have certain disadvantages, right? They're trying to become agile. Small firms generally are already agile. So you'll have certain advantages as a small firm that no matter what kind of data a big firm has, if you are resourceful in how you manage your firm, you can build certain other differentiations.
So here's another question. In B2C, there are large amounts of data based on numerous transactions with consumers. In B2B, a supplier may only have a limited number of customers. What impact does this have on the use of AI? I think, again, this is a valid question, and your concern is right. Look, the thing that is available in B2C is not a large amount of customers, but perhaps a large amount of data on installed base, machinery, sensors, IoT kinds of data. It does not necessarily have to be customer transaction data. If it is a large amount of data on any of these things, you can obviously use it for purposes that's all. So for example, for supply chain optimization or something like that, if you have IoT data, if you've got data from a good number of sensors that are giving out data all the time, without a doubt, you can train a machine learning model that can be very, very useful.
And that's a super point. And the reason is as follows. Both Amit and I, we work with a ton of B2B firms.
Indeed, yeah.
What is one of the biggest challenge if you're a B2B firm that is selling through channel partners is you often do not know your customers and you know very little about how your equipment, etc. is being used. And here we are talking physical here. Okay. Now, once you have IoT embedded into your products, for example, for the first time ever, I can get data directly on customers. I open up the black box in terms of how my products and services are being used. There is no channel partner who can give me that level of insights, right? So I think if you think about, some of the barriers B2B companies working through channel partners have faced in building customer relationships, this is a great age. Because for the first time, you will get visibility into things like you never had visibility, provided you can find ways to get that data, right? That you've come up with creative, pricing agreements that your customer is willing to provide the data. They need to have confidence that you will not abuse that data against them. And so, AI will be a mechanism again for analyzing the data, but there are all these other business things that need to come in and fall into place in order to make it work.
So Alex has a question that says, I noticed the terms AI and ML are often used as synonyms, but are they the same or what are the differences? They are indeed different. AI and ML is not the same thing. They should not be used synonymously. In our course, we will get into the details of the differences. Unfortunately, right now, we are not in the position to actually discuss that. But in the course, we will get into those kinds of things. And in the interest of time, I'm going to move on to other questions. Yeah. So going back to Vladimir's question, so he said he corrected that NPV was net present value, like you said, Gautam. He says, do you propose traditional indicators for the evaluation of investment in machine learning-based solutions or other approaches? I think this is a valid question. So should we use indicators like NPV to evaluate investments in machine learning, or should we look at other approaches?
I'm not really sure, at the top of my mind. I have two thoughts going through my mind, Vladimir. One, of course, you can take a traditional NPV approach, right? But remember one thing, right? NPV is just a formula. Right. Think about how many companies have made acquisitions based on using NPV and other things, and most acquisitions still fail. Right. So let's not think about the formula only. And so, NPV is one way in which you can assess. But I think you really want to think more deeply from a business perspective that if you invest in AI, meaning you're building the capabilities around AI, now, remember, those capabilities are meaningless if you're not getting good data, right? So now, if you're getting data that you've never got before on how customers, for example, are using your products, right? I think it's going to be super hard for you to evaluate that with a simple NPV model because you do not know what you don't know. Most NPV models are accurate when you look at your current state and you're going to progress maybe 3%, 5%, 10%, then I can do pretty accurate NPV models because I know exactly what the potential growth rates might be, and I can come up with a range. Just as a precaution, I can say in case it's 3% versus 6%, whatever, right? And then NPV models can be useful. But what if the data is going to start completely new areas of business? As a simple example, when Amazon is investing in a lot of these technologies, and in AI particularly, it probably never realized that one day it can sell marketing services to suppliers. that it can get into the advertising business and become a competitor to Google. Now, if it didn't invest in those AI capabilities and didn't get that data, there is no way they could have got into those businesses. Now, when they invested in them, if you asked Amazon, what is the NPV on this? Whatever NPV number you would have come up with, you might as well burn all copies of those reports because it would be pure garbage. So as long as you're looking at today's state and improving today's state, yes, NPV models will work. But if you're looking at breakthrough, leapfrogging, new business opportunities, there is no NPV model that is going to give you something accurate.
And just to add to what Gautam said, let's understand not just NPV, but basically all of the metrics that we use today in business. They're basically born out of convenience, right? This is the data that we can collect, and this is the kind of analysis that we can do today. We don't choose them because they are obviously the best metrics available. It's that they're easy to calculate, easy to collect, and easy to understand. So just to kind of add to it, these will probably change as we become better at collecting new data, analyzing it, and then understanding what they say. So that's that. There's actually a set of related questions which I want to kind of combine together. David Branch says, can you talk a little bit about AI and program stock trading and where you think we are on the curve mentioned earlier? Klaus talks about HR applications, and then James Wentworth asks if you're going to cover industry-specific uptakes of AI. And the previous two are obviously industry-specific or function-specific kinds of applications of AI. And he talks about AWS Novartis strategic collaborations and stuff like that. I guess in the interest of time, perhaps what we can say is that, we probably cannot address all industry-specific stuff right now.
Or just take 30 seconds on each of them.
Let's do that.
On the industry-specific, no, I don't think we're going to deep dive into any particular industry. But I think if you think about the applications of AI, they cut across so many functions that it doesn't matter what industry you're in. Right? But in some industries, maybe it will have a bigger impact. Like I'm going to talk about retail and transformation of retail through AI. So that's a very industry-specific case study, right? My colleague is thinking of talking about scaling AI, looking at B2B in the B2B space. So we will have those very specific examples, but a lot of what we talk about will cut across all industries because the applications are so widespread. I have no doubt that you'll find how to use it in your own industry.
In terms of HR, just to add again in 30 seconds, I'm actually working currently on a research project that looks at the application of machine learning for recruitment, for example, which is obviously squarely an HR functionality. And we will be talking a little bit about, or I'll be talking a little bit about the ethics of it, but also, is it working? Exactly how is it working? How do you even define whether machine learning is working? Do you define it, and this kind of goes back to Vladimir's question, do you define it as saying it's giving me a positive return on investment? Or do you define it by saying, I'm spending the same amount of time and effort, but I'm getting better candidates in the context of HR. I'm getting better outcomes. This is not a straightforward, or getting different outcomes. This is not a straightforward question to understand, but this, in the context of HR, in the functional area, since I happen to be working, we'll be discussing that in the course.
I think, Vladimir, in terms of the organization of AI, I don't know if there's just one way. I think a lot of it will be depending on your strategy. Even today, for example, when I look at certain banks, some banks have said, listen, digital transformation, we are all in. It starts in the core and we are all in. This is like the DBSs of the world. Then I look at the INGs of the world, they're all in, right? In fact, they blew up their organization. Mm-hmm. Now, if I look at a Citibank, for example, they're like, no way we are all in. We don't want to mess around with the rest of it. This is going to be a separate group, and they're going to focus on it. So we can give you examples of structures, but you'll have to assess which one might be the best fit for your particular need.
Similar a train of thought. George wants to know if can AI be used in sales departments and especially for field salespeople. Gautam and I both know organizations who are already doing it. They're already using some versions of either expert systems or machine learning to help the salespeople in the field near real time. I would not say real time, but near real time kinds of applications. We will talk about them.
As a very, in 10 seconds, one company we're working with is experimenting with what is the right pitch for a salesperson to make in the 30 seconds or 1 minute they have with a retailer on the ground in India, because they're not going to give you more than 1 or 2 minutes. What products should we pitch to them?
Absolutely.
So that's a very simple example of how it is being used in a sales pitch.
So I guess in the interest of time, we would like to first thank you so much for taking your time and effort to be with us this afternoon, morning, evening, depending on which part of the world you're coming from. Really, really appreciate your presence over here. We hope this has simulated your thinking, right? I mean, obviously, this webinar was not meant to provide you with all the answers in 60 minutes. That's not going to happen. But at least we hope that it stimulated your thinking with respect to artificial intelligence, machine learning, and more importantly, the strategic applied aspects of these things.
Excellent. Thank you, Amit. I think, just remember prediction.
That's it. Thank you.
Take care. Good luck.